Okay, so good morning, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor. And of course, if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. And of course, if you're having challenges in physics, in chemistry, mathematics, and biology, make sure that you inbox me on the WhatsApp line, which I'm going to write on the screen. Okay, on the WhatsApp number, which I'm going to write on the screen, which is going to be a plus 26077 66 40 46. So this is the WhatsApp number that you are going to inbox me on. Today we have yet another interesting question, and this question is in physics under motion, where we've been asked to find the particle speed at 10 seconds and also the speed at exactly 20 seconds. Then we have also been asked to find the distance traveled in the first 20 seconds. So this question is quite complex. It's very simple actually, except that it is a little bit complex. You are supposed to go deep into motion. Okay, so one thing that we have been given from our data, we have been given the time, okay, which I can just say T1 is equal to this is going to be at 10 seconds, and then this is going to be time 2 in consideration. This is going to be at 20 seconds for the first one. Then we have been asked to find the particle speed, but we know that the speed, okay, implying the velocity, is equal to the initial velocity plus the acceleration multiplied by the time. Okay, that is exactly the formula that you are going to be using. So to calculate the first question, we shall utilize the given formula. So this is going to be velocity is going to equal to initial velocity, okay, initial velocity of VO plus AT, implying the product of acceleration multiplied by the time. So now the first question is saying we find the particle speed at 10 seconds. So of course at 10 seconds, of course U is going to be 0 because the initial is always 0 mostly, okay, if it's not been given. So of course you're going to get your acceleration. What is your acceleration? Remember, this is an acceleration by time graph, okay. So it's an acceleration by time graph. So what do I mean by that? What I mean is you have the acceleration in the y. It's different from a velocity time graph. This one is an acceleration time graph. You've got the acceleration in the y measured in meters per seconds. Then you've the time in the x, okay, measured in seconds. So what it implies is you are going to get your acceleration at 10 seconds. So what was the acceleration at 10 seconds? The acceleration at 10 seconds is here, okay. So this was the motion at 10 seconds. At 10 seconds, the acceleration was at exactly 2. Okay, 2 meters per second. So you are going to get your 2 meters per second. You are going to put it there, and then you get your time. What was the time? It was 10. So you are going to put it there, and then you're going to say 2 multiplied by 10. This is going to give you a 20.0 meters per second, and that is how you are going to find your speed. Then you go to let me just say this is A1. This is 1B. So we go to 1B. They're saying, and at t is equal to 20 seconds. Now I want you to look at this. you have this particular motion from 15 to 20 seconds. From 15 to 20 seconds, this was the motion of this particular particle. This was actually the motion here, okay, for this particular particle. But if you've checked, they've labeled for you like this. So all you have to do, we are going to get this particular shape. We know that this one implies the shape of a rectangle, and then when we get it, we know that from -3 up to 0, that distance is just -3. Then we know that between 20 and 15, okay, if we subtract, we are going to find a 5. Okay, but notice that in the y, what we have is the acceleration. In the x, what we have is the time. So in this case, we have the time, and we have the acceleration. So in this case, we are going to use the same formula. Velocity is equal to the velocity initial, which you can say u, or if you want, you can put your v0 or v initial. This is going to be the product of the acceleration multiplied by the time. Then what you're going to do here, where there is acceleration, you're going to put -3, because that is the acceleration for this particular motion there. So you're going to put your -3 there, and then you're going to put your time. It is at 20 seconds. Then it is at 5 seconds. Okay, 5 seconds. 5 seconds. So you're going to put your 5 seconds there, and then you're going to get your -15 meters per second. Okay, that is exactly how you are going to find the first question. It's quite simple. Now the second question is saying the distance traveled in the first 20 seconds, and they are giving it 5 marks. Now in physics, whenever you have been given a question and the question is having 5 marks, or let's say 6 marks or 8 marks, it implies that there's quite a lot of things that you are supposed to do. Now, in order for us to find the distance for this particular motion, we know that velocity is equal to the displacement over the time. The displacement over the time. So even our concept, in order for us to find the distance traveled, we shall be, because we want to find this particular guy here. So if we want to find x, then it implies that x is going to equal to v and t. So what does this mean? It means that for you to find the displacement, your displacement is going to be dependent on 2 factors: the velocity and the time. Okay, the velocity and the time. So what does this mean? It implies that you'll be using the velocity time graph. We shall be using the velocity time graph. Sorry. We shall be using velocity time graph. So you are going to plot. You are going to plot your velocity time graph like this. Now, when you plot your velocity time graph, you are going to use the same numbers that have been used in the question. So in this case, here we have, this is going to be 5. Okay, here we have, this is going to be 10. For the time you maintain, this is going to be 15. Of course, this is going to be 20. And I can say this is in seconds. Yes. We get to the velocity. So we've changed. This time around, we are using the velocity, and our velocity is going to be in meters per second. This is the only way we are able to find the total distance. Now, what did you find as a velocity at 10 seconds? When the time was 10 seconds, my velocity was 20 meters per second. So I was here, Okay, this is where I was. Then this guy began to drive in this manner. And when he reached at 10 seconds, we have been told that the velocity was actually at 20 meters per second. Then we have been told that from 10 to 15 seconds, it was constant. There is a straight line there. So from 10 to 15 seconds, the motion was constant. Okay, it is going to be constant. Then we've been told that when it was at 20 seconds, we found it to be negative 15, because we subtracted 20 minus 15. Okay, so between 15 to 20, we found the velocity to be negative 15. Now, since it is negative 15, remember, we are standing here. So negative 15 implies we are now decelerating. We are moving downwards. So what do? We are at some point 20 meters per second. So 20 meters per second, we subtract 15 because we are going downward. So it implies that we are going to get a 5 meters per second. So if I want, I can draw my imaginary. In fact, I just have to draw my 5 meters per second, like that. So it implies that when I start moving downward, I am going to reach at 5 meters per second, like that. Then I can take it down at 20, like that. Now, I'm going to have this particular area. Okay, I'm going to have this particular area, this area here, which is some shape. I can name this particular area as area A. Then I'm going to have another area which is going to be here. This is another shape. I can name that one as my B. I am going to have another one because I want to simplify my work. I am also going to have this one, which I can name as C. Then I'm also going to have another one, which is going to be this one, and I can name it as D. Now, from here, I can say, let me find the area for A. So area for A, that is a triangle. So it's going to be 1/2 AB. So this is going to be 1/2. Then what is my A? My A is the distance. Let's say from here to there, from here to there to 10. So that is going to be my A5 there. Sorry, from 0 to 10, it's 10 actually. So that is going to be a 10 there. It's 10. So it's going to be a 10. Then what is B? Okay. B, let's take it as the distance from here up to here, which is going to be a 20. So what is 20 multiplied by 10? It's going to be 200 divided by 2. I'm going to get 100 meters. Then we go to B. B is a rectangle. So a rectangle, area of a rectangle, the area of a rectangle is L times B. So the distance from here to there, it's 20. From this point to that point, it's 20. So I can say 20. Then 15 minus 10, it's going to be 5. And this is going to give me 100 meters or so. Then I find for C. C is a small rectangle. It's a small triangle. C is a small triangle. So I'll say area for C, this was area for B, this was area for A. So area for C is going to be 1/2. Then what is my A? My A, let me take it as the distance from there to there, which is going to be 5. then my b is going to be the distance from here up to here, which is going to be 15. Then what is it? 5 multiplied by 15, it's 75 divided by 2, I'm getting 37.5 meters. Then I go to D, area D. Area D, notice this is a small rectangle, so the distance from this point up to this point, we know that it is a 5. And then the distance from here to there, it's a 5 also. So I'm going to get a 25 meters. Then we find the total distance. So total distance is going to be 100 plus 100 plus 37.5 plus 25. And we're going to get 262.5 meters. That is how you find this video, this particular question. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you.